Hey everyone, good evening. Good evening to all guys. Hi, Code with Akash. Good to see you again. Hi, Insane. Hi, Ankit. Hello, guys. Am I audible and visible to you all clearly? Can you give me a thumbs up or yes or no in the chat, please? I know we are late for almost 15 minutes. There was some network issue from our end. I don't know why. Last minute, some network issue occurred. But yeah, now we are good to go. And sorry, so sorry for keeping you guys wait. Uh, no, Akash, I'm not a trainer. The trainer is Ekta ma'am. She will be teaching you, like guiding you on how to build your AI model. I'm here just for the introduction part to let you know the attendance thing and how you will be getting your certificate. Good evening, Pawni. Guys, I hope I'm audible to you all very clearly. So let's start with the session. Let me tell you about myself first. My name is Anam Khan from LetsUpgrade, and I'm here to just welcome you all that for the building AI model, your first AI model, and it will be a 3 days. It will be a 3 days boot camp, and each day it will be 1.5 hours session, and I hope you will be enjoying it, and the timing will be from 6:30 to 8. So please make sure to join on D2 and D3 as well at 6:30 p.m. sharp. And I will share my screen in a minute, within a minute, to explain you all the attendance part also. And yes, the certificate is free. It's totally free. You don't have to pay anything. No fee, no charge, nothing is there. You just have to mark your attendance, and you can unlock your certificate on day 3 when the session will get end. After that is after the 8 p.m. You can download your certificate right from the attendance page itself. Okay, so thank you, Dasun. Thank you. So let me share my screen. Yes, it takes around 500 LU coins to unlock your certificate, not 800. Yeah, so I hope my screen is also visible to you all. No worries, insane. You can after marking, when you mark your attendance, you get some 50 or 100 LU coins, and also by enrolling in any of the program or referring the boot camps, you also get the LU coins. So you can earn the LU coins by marking your attendance or by enrolling in the upcoming programs. Okay, coins you get by marking your attendance, guys. And so if you don't get you, if you still don't have much coins to unlock your certificate, you can enroll in our upcoming boot camps. Okay, yeah. So guys, I hope my screen is visible to you all. Can you give me a thumbs up in the chat, please, once again? Then Lakshmi, in your Let's Upgrade profile picture, there wouldn't be like your correct spelling of the name, or it will be in a different font. Please use the normal font. Okay, then and you can then regenerate your certificate again by whatever name you want in your certificate. Okay, this session will be a 1.5 hours ka, and it will be 3 days boot camp. Okay, so okay guys, thank you for response. So moving ahead, for the attendance part, you can see in the description box for registration, attendance, LU coins, everything, we have this one link. We call it as a one link as everything is placed at one place. So you need to come to this page. A new page will open. One second guys, I need to stop sharing my screen. Yeah, yeah. So here is my screen. So guys, as you saw, like to enroll in the program, it will ask you a OTP. So you need to enter your mobile number, and then put the OTP here, and then you will be like enrolling in the program. And to mark your attendance, you definitely need to enroll in the program first. And when you scroll down here below, beside the day one title, you can see mark attendance toggle. Click on it. A rating scale will open from 1 to 10. Arre? Huh. like here is a rating scale, so I will give 10 on 10 for now, and here is a feedback option. If you have any feedback for us, be it positive, negative, or whatever you didn't like in the session, or you want any improvement from our side, then you can freely put it here and we will surely work on it. And then you need to click on mark attendance toggle, so your attendance will be marked, and here you can see your progress bar. It will increase day by day as you mark your attendance. For now it is 33, and by the end of this boot camp it will be 100%. And when the session will end on the day 3, then only after 8, that is after 8 p.m., you will be getting to generate your certificate. Right below from this below this progress bar, you will be getting to download your certificate, so you can download from here itself, so you don't need to go here and there. Okay, I hope I'm clear to everyone how to mark your attendance. And still not, if you still didn't get it, you can just rewind the video and watch it again, as it is a one time process, so I cannot undo it. And if you have any like these, also we have this communities WhatsApp and Discord, you can join us there to get regular updates, daily invites, upcoming sessions reminder, bootcamp alerts, and many more things. Also you can connect with Let's Upgrade. We also do provide internship opportunities, so you can join our communities to get those things. And you can connect with your friends to, like, if you're stuck somewhere, you can clear it out by getting the help. Okay, and we have this all-in-one documentation, guys. So when you click on this link, a document will be open. Here we have put all the thing, like all the links, the attendance links, session links, and also the course outline. This is just an outline that we are going to follow for the next 3 days to build your first AI model. You can refer it, and also you can save this link, as we will upload all the resources here. If ma'am shares any of the resources, any PPT file or any link, we will upload all those things here itself. So you can please make sure that you save the document link, as this document cannot be downloaded in the PDF format. So to refer it any time, please make sure you save it. Okay, so one more thing, guys. We have the student ambassador program, that is a free 1 month program. Here, by applying for the ambassador program, the which is starting from the, as it is a 1 month batch, so the next batch is starting from the 1st of July. So when you will apply, the team will connect with you by the 30th of June, and informing you about your selection process. And if you got selected, then you will be the ambassador for the Let's Upgrade for the next 1 month. And there are certain targets that you need to achieve there. You get and also there are benefits, like you get to attend exclusive workshops, get certificates, get swag, get to win Amazon coupons, and also many more things are there. So when you will apply for it, we'll get to know these are the prizes that we give away, and these are the milestones that you need to achieve. Okay, so you will get to see your apply now button. Please make sure that you apply for it and be the ambassador for Let's Upgrade for the next 1 month. Okay, so this was it from my side, guys. If you still have any question, you can join our channel or rewind the video to check how to mark your attendance. Okay, so I will call the trainer for now, that who is Ekta ma'am. And hello ma'am, good evening.
Hello, am I audible?
Yes ma'am, you're audible.
Okay, thank you. Good evening. Hello, hi everyone. I hope everybody's excited to learn about this.
Yeah, I can say they are super excited. So without wasting much more time, I will take a leave and hand over the session to you. So bye everyone, bye guy, bye ma'am. So see you all soon in the next boot camp. Bye.
Sure. Great. Hi everyone. Good evening. I hope I am audible and you all can listen to me clearly. Today we are going to be learning about something very, very interesting, that is build your first AI model. And I'm sure that everybody is extremely, uh, interested in learning about that and very, very enthusiastic about the concepts itself and what they will learn overall in the process. So I hope everybody is all geared up to learn about this and all set to really go ahead and see how these things are going to be working ahead. Like, how do you actually build an AI model? So, let me just share my screen meanwhile so that I can just present. Can somebody just confirm if my screen is visible on the chat? Somebody can. I think it should be visible. Right. Okay. I think that's great. Everybody is able to see this. So we can start now. Okay. I will keep answering all the questions as and when we go ahead with the different topics. So just hold in your questions, put them in chat after each module, so that it'll be easier to, answer all of them together rather than, me missing out on something that you would have asked before. So it would be great if you can just put in those questions all at one point of time, like after each module. So since there are three modules on every single day, what we'll do is we'll try to take the questions after each module. Okay. So that we don't miss out on any. All right. So let's start. So the first thing is all about our topic for today, which you all are very well aware of and pretty much excited about, as I can see. So that's exactly what we will be going ahead with and trying to uh, make the best of it, right? So, who am I? Let me give you a quick introduction about myself. I am Ekta and I'm currently working as an associate data scientist at MSCI, which is Morgan Stanley Capital International. I have had more than 7 years of work experience working in different companies across various domains, primarily Quantify, Viacom 18, General Mills, and BNP Paribas. So I come with a lot of experience from different spaces. So I do have experience looking at a lot of data and solving different kinds of problems and how we can really work around with it. Is my voice audible now or is it breaking? I'm just trying to see. I did look at the chat. Am I audible now correctly? Somebody said my voice is breaking. Can somebody just confirm on chat? Is my voice breaking currently or not? Can you hear me? Audible? Not breaking? Okay, fine. I can see that I'm audible, and that's what people have replied on the chat. So, yeah, that's all about my previous work experience. And I also like teaching. So, I've been a visiting faculty at various business schools and also different training and learning institutes. So, I've been a visiting faculty at Masters Union School of Business, NMIMS, which is a management school in Mumbai, BITS Pilani, Bombay Stock Exchange, as well as Scalar. I am also a data science mentor at Preplace as well as TopMate, where I am available for any kind of consultation that you need. Uh, where what you would really come across is majorly people who need some or the other kind of guidance. And I typically love solving all kind of problems. So that is my major forte, and that's what I work on typically. And that's what makes me a differentiator in my space. So yeah, that's a little bit about me. Let's look at what all we are going to be covering. It's going to be very, very interesting for everybody. So it's about introduction to machine learning as well as model building. So that is going to be our day one, typically, where we look at these aspects. And we have three different modules which we'll be covering in three different parts. So majorly each module will last about 20 minutes. So 15 to 20 minutes for each module, where at the end we'll also do hands-on, that is we'll build a particular code. We'll try to write some code on a Google Colab file and you all will code along with me. So that would be very, very great, right? So it would be a good exposure for you guys as well to be able to, write good code, right? So we'll be doing this in the third part of the module. So the first part of the module is a little bit of introduction about what is machine learning. And then in the second module, what we do is we go ahead with working with data. So what we'll do is we'll meet the iris data set, which is the one with which we'll be working around. Okay. And the third will be building your first ML model, right? So let's start with, what is machine learning? So all of you guys have heard about this term a lot, I'm pretty sure. ML, machine learning, AI, a lot of us have heard about this, right? So This is something which is very, very, common today, right? So that's exactly what we are going to be getting at. That is trying to answer the question that what is machine learning? And then let's look at how to work with data and so on. So machine learning, typically, like if I have to explain in the most layman terms, what is it? It's more like explaining a younger child to learn about the different techniques and different life skills to go ahead with life. So say a very young kid, like say a 2-year-old kid, is starting to learn to walk with a parent's guidance, right? So your parents are actually teaching you by giving you those instructions that you can hold your hand, they can hold your hand and you can, walk along and get that support. What is that? This is nothing but you are you can say that you are that machine who is being trained. And who are you being trained by? You are being trained by your parents because they have already seen how you would really learn as a human and how you would really go ahead and work, right? So that is something which is a very, very interesting perspective of looking at machine learning, right? So now let's understand it from perspective which will help you to gain better knowledge. So these are the four major topics that we will cover in module 1 under what is machine learning. So there is a difference between traditional programming as well as ML, right? So what is the major difference between the programming that you have learned in college? So I think most of you are college students, right? Since that is something which is very, very prevalent, you will tend to see that, right? That what is really happening over there, correct? So what is happening there when you say that, there is a lot of difference? You would have used Python, C++. What other languages are you guys aware of? Any other language that you know programming in? Like, do you know about some other things? Which programming language is something that you have learned about? Have you learned about C++? Which other language? I'm seeing the chat. You have mentioned, some of you all have mentioned C, some have mentioned Java, Kotlin, then Python. How many of you guys know Python? Some of you all know Python. Okay, great. So we are going to be coding in Python today, which is our major, major task because machine learning itself is something which is highly based on Python. So we learn what is the major difference between Python, which is a programming language, as well as machine learning, which is ML, right? That is one thing. Secondly, there is types of ML, which is nothing but supervised machine learning, unsupervised machine learning, as well as reinforcement learning. Okay. And the third one is reinforcement learning. So have you heard about reinforcement learning as such? Has anybody of you learned about reinforcement learning? Okay. Okay. Fine. Some of you have heard about reinforcement learning maybe in college or somewhere else, right? That is one. Okay. Then the third one is we look at real world examples of ML in daily life. Like what are the regular examples and all. And what is the ML project life cycle? So we'll understand about that also in simple steps. Okay. Okay. Y'all are mentioning that there is some background noise. Just give me a second. I'll take care of that. Is it better now? Can you hear me clearly? Are you able to hear me now clearly? Can somebody just confirm if there is any noise now? Can somebody just answer whether you can hear me or not? That would just help so that then we can proceed further. We have a lot to cover. Okay, great. Now we begin and we start with the concepts that we have to cover. So the very first thing is about covering the difference between traditional programming language as well as machine learning, right? Uh, okay. Mm, the major concepts when we talk about programming as well as machine learning. So think about it like the on the left hand side, think about it that you've learned about one programming language, right? Like till now, everybody is aware of one of the programming languages like C, C++, Java, or Python. So you consider that on the left hand side. Okay. And then on the right hand side, what we have is nothing but machine learning, right? So when we have machine learning on the right hand side, what we see is there is a difference in the programming style, right? Like when we are using Python, we or C or C++ or Java, we have explicit rules. We say like if day equals to Wednesday, do this, right? Whereas in machine learning, that's not the case. What is the scenario then? You learn from data trends. You learn from data patterns, how things work. Okay. So that's how things really are with respect to machine learning. That is, take data and try to understand the inherent patterns in it, what kind of trend it's showing, and so on. That's what is the primary agenda of machine learning. Next, what we are talking about in terms of characteristic is the data's role. What is the data's role in terms of the programming? Input to program. So when we are working with Python, we give it certain input, right? Like we give it certain input that, okay, this is the input, like the name of the person, and you want to print the name of the person, right? That is one thing. Second, what you see over here in terms of machine learning, you have training data. So when you say training data, I'll give you a very good example. So say for the past 5 to 10 years, you have weather data which the meteorological department has collected, right? Like on every day, what is the um, temperature, what is the wind speed, what is the humidity, what is the air pressure, and so on over the period of time. Now it has collected all of this data. Now we should be making the best use of this data. So what does this data help you do? It helps you to make predictions. That is, what will be the temperature tomorrow? What will the temperature in an hour? Say it right now it's 7 p.m. At 8 p.m. what will be the temperature and so on. That is something which is the work of the meteorological department to be able to do, like to be able to have prediction models, right? Which will help you do all of this. Correct? So this is exactly what is your training data. That is your historical data that you have collected. Next, what we are talking about is problem solving. Okay. So when we talk about problem solving, we are saying we are defining steps. So when we write Python or C++ code, you define steps, right? You declare a variable, you then set a value to it, and then you work ahead with it. Like that is how you typically progress in a problem solving approach, like you're doing steps. But when it comes to machine learning, what you're doing is the algorithm itself will learn the patterns. It will try to understand what is it in the depth, what is really going on, what are the trends, what are the patterns, and on the basis of which it will give the next decision or prediction. Next, what we talk about is learning. So in traditional programming, you have rules which you have defined. Like if day equals to Sunday, it's a holiday, right? That's a rule. Whereas in machine learning, there is no rule. There is continuous improvement. So on the basis of the past weather data, you will predict the future weather data, right? That's how it works. So it's continuous improvement. There is no such model that is taken into consideration and it does not work with that, right? Next is adaptability. So when it comes to traditional programming, like that is Python, there is limited adaptability. It cannot, change itself and work around itself with respect to the program that you've written. What will happen is it's restricted. That is, if you've written if day equals to Saturday or Sunday, it's going to consider it as a weekend only. There is no change or learning that will happen in the process. Whereas in machine learning, there will be very high adaptability, right? That is what will be the case. That is what you will see. Now, when we talk about use cases, in traditional programming, you have very well-defined problems. So when you say you have well-defined problems, what does it mean? That you have created a program which will say that Saturdays and Sundays are weekends. So that is a well-structured, well-defined problem. Whereas in machine learning, what you are solving is a complex problem. Okay. What is the goal of traditional programming? To follow instructions. Whereas what is the goal of machine learning? It is to learn from the data. So that is the major difference that you can see. A very major difference. That is, everything for machine learning is related to data, whereas in traditional programming, everything that you have is rule based. So you have rule one, rule two, rule three, and that's how you move ahead and work. So this is the major difference between traditional programming and machine learning. I hope this is clear. If anybody has any questions, please put them down on the chat window at this moment, and only relevant questions. Please don't spam the chat because it makes me miss important questions which might come on your way, right? Which somebody else also wanted to ask and did not ask. So that's the reason why I would suggest you to not spam the chat. So if there is any question with respect to whatever we discussed till now, traditional versus machine learning, please ask me the difference, else we'll move ahead. So the next topic that we are covering in the module one is types of machine learning. So we have four major types, you can say, or three major types. Semi-supervised learning is just like a branch of it. But when we say supervised learning, what really happens in supervised learning? You learn from labeled data. So when I say labeled data, what kind of data does it work with? So see, if I have to build a model, a software which is going to be able to distinguish between what is a cat and what is a dog, what will I have to do? I will have to feed it in pictures of cats as well as dogs, right? And tell that to it. That, okay, this is a cat and this is a dog. What are we doing in the process? We are labeling the images, right? So when we do this, what is supervised learning? It is nothing but having labels to your data. Okay. So that's exactly what it's able to do. That is assign labels to your data very clearly. In the second machine learning type, what do you really have? It's nothing but unsupervised learning. So when you say unsupervised learning, what really happens in it is you're trying to find patterns in unlabeled data. So what could be a good example of unsupervised learning from your understanding and from your examples of whatever you know? What it really means is that uh, you have data of customers. Say every bank has data about its own customers, right? So when you have customers data, how do you identify which particular customer to target for selling their products? So all of us get calls, right? Like, okay, can you buy this credit card? We do get those calls, right? All of us get those calls. How do you think that they decide to target you as a person to buy those particular customers, like those credit cards? How does that happen? कैसे होता है? It happens through a process which is unsupervised learning, that is clustering. You are grouped together. Say I stay in area A and my friend B also stays in area A. Now we stay close by. I have a friend who's staying by in a closer building, like 5 minutes away. Now we have similar characteristics. Now, what kind of similar characteristics when we are saying? When we say that, what it means is um, the fact that it will have similar characteristics. So when you have similar attributes, similar characteristics, what will happen? You display similar habits also, right? Like, I mean, that is what exactly we do. That is, we do try to, as if we look at our friends also, we see that we are both similar. Okay, we'll have similar activities, we'll be displaying similar habits and similar things. So when we do that, so if A has a credit card, then you can also pitch the same credit card to your friend B. Why? Because that person is likely to buy that. Possibility ज्यादा है कि वो भी खरीद लेगा इंसान. उस credit card को, right? That is quite possible. So when this happens, this is nothing but a very good example of unsupervised learning. And what is semi-supervised learning? It's a combination of both labeled as well as unlabeled data. Now, what is reinforcement learning, which is the fourth type of machine learning problem? Here, you have an environment. किसी ने पैकमैन गेम खेला है? पैकमैन या फिर ऐसे कोई भी गेम where you have to try to achieve a certain goal. Whenever you're trying to do that, it's a game. So in a game, what happens is at the back end, you have nothing but a reinforcement learning setup, an environment, right? तो उस environment में क्या होता है? Once you step into it, you are given certain points. Like when you're playing a game, when you achieve certain, goals, you get some points for it, right? So when that is happening, so what is your benefit? You are getting those points, right? When you get those points and you achieve your goal, that you reach your goal, like Pac-Man is what you have a typical path, right? And you go from one star to the goal and you find out the best goal, correct? So when you are trying to do that, in the process, whatever addition you have with respect to the points that you earn, or you lose certain lives also, right? When you're going through that, like even Mario is similar to that. Whenever this happens, what is happening in the process? The backend is nothing but reinforcement learning environment, where it's going to maximize your reward through trial and error. So whatever trial and error you're doing, you'll try to maximize that reward that you're getting. So reward is nothing but your points that you gain in the process, right? So that's exactly what is the fourth type of machine learning category. Now let's talk about practical examples, because I think that is something which will interest you guys a lot. So I'm typically looking at the chat now. Just tell me, like, what are the kind of machine learning examples that you've seen around you? I want you to give me examples, only examples from around you. Maybe something that you see in college, on TV, on laptop, wherever you see. Where do you think you can see those kind of things? Can anybody write relevant examples? There are no examples. Spam filtering. Okay. Spam filtering is a very good example of supervised learning, because you have emails which are being categorized into spam or non-spam, right? That is very good example. Second, Netflix recommender system. Yes, recommendations are nothing but uh, it is something which is based on what one user is giving to the other user. So if one user is watching a certain show, then that same show is recommended to the other users as well. So yes, YouTube, Instagram Reels, all of that is a very, very good example. Yes, all of that is using recommendations right now. Okay. YouTube, chatbots, yes, all of these. Spotify is also a very good example. So that is also very, very useful. I will take your question, what is reinforcement learning in simple words, after this module. Okay. So make sure that I just remind me in case if I do. I will answer that. Customer segmentation is the best unsupervised learning example. Absolutely true. That is the best way in which you can categorize things. So email spam filtering is a good example, as we mentioned, right? It's a simple machine learning example. Second is music recommendations. So what does music recommendation do? It will suggest you music. So Spotify is a good example there. Online shopping. So what happens in online shopping? Personalizes product recommendations and pricing. How does this happen? Through Amazon, Flipkart. It gives you recommendations right below. It gives you that what kind of recommendations should be given to whom, based on past purchase history and purchases and so on. Then you have virtual assistants, right? So when you talk about virtual assistants, they are something who will help you with your tasks. So if you have to keep an alarm today, do you really have to go to your alarm in the phone? Can you do that without the alarm in the phone, like without going to that app? Is there a way to do that? Does anybody have an idea? How else can you keep an alarm without going to the time or alarm app? Any idea? Nobody has an answer. कुछ तो सोचो. अगर वैसे नहीं करोगे तो कैसे करोगे? Somebody mentioned Alexa, which is right. Alexa is a voice assistant which can be used. Google Assistant, yes, that's absolutely correct. Bixby voice command, yes, you can use that also. Hey Siri, set alarm for tomorrow. Yes, exactly. So what are these? These are nothing but your ML tools which are running at the back end, right? So these are your virtual assistants. Then you have navigation apps, optimizes your routes and predicts arrival times. Which is the app which we use for route tracking? Which one is the one that you use for route tracking, all of you guys? What do we use? Do we use Google Maps? Do we use Uber? Do we use Ola? Do we use any such similar apps? We do use that, right? Google Maps is a very good example of optimization, right? Now let's look at a typical, so since you've understood the examples and you can correlate now, let's look at a typical machine learning project lifecycle. Okay, so what happens in a typical project lifecycle? That is very, very important for all of us, right? It is a set of steps which all of us will follow on a day-to-day basis, right? We will have to do that, right? So here, if you look at the bottom of the screen, the very first step is problem definition, right? So when you say problem definition, what are we doing over there exactly? We are going to be defining what our objectives of the ML project are going to be, correct? Very, very important for all of us to be able to do that, to define the problem statement. Then next, what we do is we do data collection. So whatever data is required for solving the problem, say we want to build a Netflix recommender system, like the recommender system which is there on Netflix, we want to mimic that. And if we want to do that, the very first step is to define the problem. So we're going to define the objectives of the ML project. So recommender system, it has to be near, it has to be exactly like what the current recommender system is. So that is going to be one of the objectives. Next, it has to be able to recommend good shows to you. So the performance has to be very high. Then it has to also cover all the genres. It does not have to be biased. So these could be some of the objectives. I'm just giving a rough idea, a rough example of how the objectives could look like. Okay, so defining the problem statement is nothing but your first step. All right. Now, what is your next step? Next step is data collection. So you gather all the relevant data from your various sources. That is your next step. So your data could be present on multiple sources when you're trying to solve a problem, right? So you'll have to pick it up from, say, the SQL database, say from Postgres database, say from Oracle database, say from Google Maps, anywhere. I mean, the data could be lying anywhere, right? So you will have to collect all the data. Next step is data preparation, right? So when you say data preparation, you will do what? You will clean, transform, and format the data for ML use. So all the data that is lying could be very scattered and may not be in the format that you'd want it to be, right? So for that, what you do is you'll have to clean the data and prepare it in a certain format so that it's structured and can be used further. So that is nothing but your data pre-processing or data preparation. Next, what you do is exploratory data analysis. That is, you try to understand the data trends, the patterns, as well as correlations from the data itself. So you try to create charts, graphs, so that you can get to know insights from your data, which is something that would have been missing otherwise. Okay, so that is nothing but your EDA process, exploratory data analysis. Next step is your model selection. So for every kind of a project or objective of the project that you're trying to look at, you have a certain set of models which you can apply to it. Now it's very important for you to choose the right algorithm for the task. Extremely important. So once you've done that, like you have your model selected and in place, it's great. You can work with it ahead. Once you are done with your model selection, what you will do next is you will go ahead with model training. Now, what happens in your model training is a major question. So that is nothing but you will feed your data, which is your historical data, say your weather prediction model that we were talking about. All your historical data, that is nothing but your data from 5 years or 10 years before, is going to be fed into the algorithm so that it can learn from the patterns. It will say that, okay, July, May, the temperatures are around something like this, and it will always rain during this time. Just giving you an example. So these are the kind of patterns which it can uncover through EDA and then be used in model training. So once you've done model training, next step will be to evaluate the model, right? Now there are multiple algorithms that exist in the model training aspect. We look at them step by step. Some of them we look at it. The one that we are going to be using today is one of the scikit-learn basic models, which we will learn about it in the next modules. So there are several models like logistic regression, linear regression, decision tree classifier, random forest classifier, random forest regressor, XGBoost classifier. These are just names, jargons that I'm making you aware of, which we will use further on in the session. So don't worry about it. Next, what we have is model evaluation. So what happens in model evaluation? You will test how good your model is performing. In that case, what you will do is you will be using some metrics to judge how the models is going to be performing on your training data as well as your testing data. We'll understand the process of what is testing data and what is training data as well. After model evaluation, your next step is model tuning. So you will improve the performance of your model via hyperparameter tuning, which we will learn about further in the steps ahead. But this is nothing but trying to continuously improve your model. Hyperparameter tuning is nothing but making your model better. Continuous improvement is what we are looking at. Okay. Post that, what we are looking at is deployment. So when we say deployment, what we want to do is integrate the model into a live interface so that it's usable further. So say any model which is on Streamlit, where you click on a URL and you can utilize it. I mean, you can try to give it some data and get some predictions. That's exactly what is your model deployment. Okay. Post that, what you have is monitoring and maintenance. So you track the performance of your model and retrain them as and when needed. So that is nothing but your monitoring as well as your maintenance phase, right? So I hope this much is clear. We are typically at the end of module one. So now I'm going to look at the chat window for any questions that you have. So if you have any questions, let me know. I'm happy to answer them. At the moment, to clear off module one in your heads, like if you have any questions related to the module, please ask me any questions so that they are clear. I want you to be clear before we head into the next module. I don't see any questions, guys. Evaluate how much they are efficient. Somebody has just shared their knowledge on the machine learning algorithms, but I don't see any question. How can we decide? You can decide based on the data and the kind of problem statement that you're solving. So it depends a lot on the objective of the problem statement. And once you have the objective, you can do a lot more things. What coding program we use in ML? We'll be using Python as a coding language. Are we going to do EDA before applying model? We'll do things step by step. Today, we'll just build a very basic model. How can we select this is the best model to use? That's a good question. So you can decide on the basis of the data that you have and the objective that you want to achieve. Okay. So that's exactly what we are trying to achieve over here. That is based on the data, we decide which algorithm to apply and which model to use. Okay. So I'll give you some tips and tricks at the end, like on day three, for you to be able to understand which model to apply. So we'll be using different kinds of models. We'll let you know about these as and when we go ahead in the session. Can you please recap what we have covered so far? We have covered very basic things till now. First one being the difference between traditional and programming and machine learning. Secondly, we've covered some basic applications. Also, we've covered the different types of machine learning, and then we've covered the machine learning life cycle, which is a typical life cycle which is used when you're trying to build an ML product, right? So that's exactly what we have covered till now. We have not covered anything except for that. Okay. And data sets are also something which you can download on your own. So it's not difficult at all. Now let's go to module two before we, answer all the other questions as well. The other questions which I have not answered, I think I have answered all of them. But if I have not, I will answer them at the end. We'll keep 5 to 7 minutes at the end for Q&A. Okay, only for question and answers. So that you don't miss out on anything or your questions are not missed out. So let's start with module 2. In module 2, what we'll be learning is what is a data set. So what are rows, what are columns, what are features, what are labels? That is what we'll understand. Then we look at the iris dataset that we are going to be using today and how its structure is. What are the features that it uses and everything. Then what we'll do is we load the datasets using scikit-learn.datasets, which is the sklearn.datasets, which is the library which is used in Python or CSV. You can do it via either of the methods. You can directly use sklearn.datasets to download it from the internet and work with it. And then you split your features as X variable and your targets as Y. So that is what we will learn in the second module right now. So let's focus on that, guys, and ensure that we have these topics clear in our heads. Okay. Meanwhile, let your questions flow in on the chat. We'll answer all of them. All right. What is a data set? So a data set is nothing but a structured collection of data. So if I have to explain to you in the most lamest way possible, it's just an Excel sheet which has rows as well as columns. Consider that as a data set, okay, which is a structured collection of data. And when you see a tabular structure, that is nothing but a structured collection that you would see, right? That is something that is expected, not something that is not expected by you. Now, what does it consist of? Okay, so what it consists of is rows. Rows are horizontal values, right? Individual samples or observations, and columns, which are nothing but your features or variables. And then what are those features? They are your input variable, but nothing but your X, and your labels or targets, which is nothing but your output variable Y. So in our case, in Iris dataset, we'll be using certain features to help for prediction. So you just have to think of it like an Excel sheet with a goal. All of us have seen an Excel sheet in our lives at some point or the other. We all have. Yes or no? We have, right? Everybody's looked at Excel sheets, I hope, at some point in their lives. So that is exactly what a data set really looks like. So now let's move to the tabular structure to just show you what the iris data set will look like. So it has four different columns over here as visible. Sepal length, sepal width, petal length, petal width, and species. So these are the five columns that you will see for this data. Now, what does this mean? It means that this is a data about the iris flowers. So iris is nothing but flower species data set. So you all know, right? There are multiple flowers which are available and you have its species. So that's exactly what the data set is all about. So you have the sepal length, sepal width, petal length, petal width. Petal we all know. Sepal is also something that we learned during our school days. So it has the measurement of it, the length and the width of it, and the petals length and the petals width, and also the species of that particular flower. And what is the highlight? The features are the first four columns. So sepal length, sepal width, petal length, and petal width is nothing but our features, and species is our label. So nothing but your supervised learning, right? So you have a label associated with it as well, which is nothing but your species, which is Setosa. Okay. So this is how our data looks like. Now we are trying to introduce our iris data set, right? So each row is going to be a flower sample. So the row that you saw over here, right? This is nothing but it corresponds to one flower, just one flower in a horizontal manner, just one flower. Okay. So that is exactly what it looks like. So each row is one flower sample. And the features that we have are sepal length, sepal width, petal length, and petal width. We know what is a petal, right? Petal is nothing but the most beautiful, smaller part of the flower, and it has a length as well as width, and it's measured in centimeters. In a similar way, you have a part called a sepal, and sepal also has a length as well as width, okay, which is measured in centimeters, and that's what the value is present in that particular data set. And then what do you have as your target variable, your predictor variable? Is your species. That is on the basis of the value of the sepal length, sepal width, petal length, and petal width, we are going to classify it as one of the species, whether it's Setosa, versicolor, or whether it's virginica. What is it out of this, right? So that's exactly what your iris data set is all about. Okay. So exactly what we are trying to target and talk about over here, that is all about the prediction of the different species of our flowers. And how are we doing that? On the basis of certain features that we have, right? Now, what are we going to use as our library at the back end to be able to load this data and work with this data? It's nothing but from scikit-learn.datasets, we will import load underscore iris. So this is the code that we have to write to load the dataset. And iris equals to load underscore iris function, which has been imported from our sklearn.datasets library. So you will load that iris function. And then what you'll do is you'll print iris.keys. So when you print this, it will show you all the keys which are there for the iris dataset. We will do all of this practically as well, so don't worry. And this typically comes preloaded with scikit-learn. So any Jupyter notebook instance that you open, like when you're writing Python code, you will have scikit-learn as a part of it by default. And it also has easy access to data, target, as well as feature names. So what is the data? What is the target variable? And what are the various feature names which can be taken as a part of it? So all of that is something which is coming along with this sklearn.datasets. And what is our sklearn.datasets? It's a library which has a certain functionality. Okay. We are going to be talking about a real world example as well very, very soon. So don't worry about it. I'm just teaching certain syntax right now over here and how we really write it. So we define our x as well as y, where x is nothing but our input features, which are used for prediction, whereas y is nothing but a target or output. Okay, which is nothing but what are you predicting at this point of time. So your x is nothing but all your petal length, petal width, sepal length, and sepal width. So we don't need the species over here. So from the entire data frame, we just drop the species column and you keep the axis as one, and your y is nothing but your species column again. So your x is nothing but your input features, which are going to be used for prediction, and your y is nothing but your target or output, which says what you're going to be predicting. So, but before this, we should always split before training your model. That's very, very important. Okay. So make sure that you split your data before training your model. All right. So this is conceptually understanding what we are talking about. Now let's go ahead and try to write some code associated with this. Okay. Now when we say we want to work with code, I'll show you what it really means. Okay. So I have a Jupyter notebook which will help me do this. Has everybody heard about Colab? Google Colab? If you just type Google Colab on your Google search, you will be able to get the answer to what you were looking at. Google Colab, does everybody know? Yeah, we are using Colab right now. Can everybody open a Colab notebook? Can you do a code along with me? Are you ready for that and excited for that to be able to do a code along? Has everybody opened up a Colab notebook? Everybody just open that. Everybody is ready. You can just type ready on the chat window and that will just give me some understanding that you are ready. Okay. I think some of us are ready. So you might see like I'll just show you an empty collab notebook if I'm able to open one right now. It would be something like this. I'm just showing it to you on the screen. What you will need to do is click on connect, which will connect to the terminal, to the Python terminal. So once this connecting is done, your kernel will be ready to execute basically. So as you can see that you get a tick mark, and all of this is set. You can write your code here and start executing by pressing the play button, which you can see on the left hand side, right? You can name that whatever you want. It's totally up to you. You can write it like, I mean, totally up to you, whatever you want to write. Okay. So that's how a completely new collab notebook would look like. Now let me just show you what we should write. Okay. So you can load using Cborn also, you can load using sklearn also. What we'll do is I'll write code on a plain collab notebook so that you can also code along with me. Okay. So what we'll do is we will load it via the method that we have learned. We learned something right now, right? So we will do it via that. So we'll do it via sklearn. So what is the code that we will write? We will write from sklearn dot datasets import load underscore iris. Okay. Now once we've done this from sklearn dot datasets import load underscore iris, then what we'll do next is we will load it. So for that we will write iris equals to load underscore iris function. Okay. We've done this much. So what has it done? It has loaded the iris dataset into iris. Now if I want to print my iris dot keys, I can do that and it will show me what are the different keys which are available here. Okay, these keys are nothing but keys which have been created for the dataset where you can access the data, the target, the frame, target names, and so on. If I want to access the iris dataset, I can see it this way. This is nothing but my data. So if I want to just, show it in a better way, I just printed iris. Now, if I just want the data, I can just say iris dot data. So when I say that, it will just show me the first four features. That is the petal length, petal width. It's an array which has the petal length, petal width, sepal length, and sepal width because those are my X features, right? And my target is nothing but what is my target? Target is my species. So since that is my target, what I will do is I will just say iris dot target, and that will give me the target in front over here. So what you can do is, first of all, you can load iris and then print this. So has everybody done this much? I gave you a minute for that for you to be able to catch up till this much. Has everybody done this much? Yes or no? I can't see anybody typing on chat, so I wouldn't know whether you are telling me that it's okay, I'm done, I'm not done. What kind of indication are you giving me? Yes, everybody is done. Okay, that's good. So we've done this loading part. Now we'll just separate it into X and Y. So while we do that, do we need to separate it into X and Y though? Can anybody answer this? Okay, 2 minutes more, somebody said. We don't need to, right? Because we already have the data as separated out as data as well as target over here. From sklearn.datasets, if you use, you don't need to separate it out. Correct? You need to ensure that. So this is something which you can do. Make sure that you don't separate it out again if you have the data present in this format already. If it's existing already in this format, you don't have to separate it. Correct? We can just assign your X and Y for your training and testing, right? So this is typically what is your module 2, right? So your module 2 was something where you were supposed to understand what is a data set, then look at the iris data set and its structure, and then how do you load the data set using sklearn.datasets. There is another way to also load the data set, which is by using a CSV file. You can do that as well. It's totally up to you how you would want to do it. But yes, you can do it that way. Now, there is another way which you can use to do it as well. That is by using your cbond.sns. So we saw sklearn.datasets and how we can import iris from there. In a similar way, you can use cbond also to load the data. So here you have loaded the data. You've used the import function, import cbond as SNS, and then iris equals to sns.load underscore dataset, and you've loaded the dataset name here, which is nothing but iris here, and iris.head function. What will iris.head function do? It will show you the top 10 records, top 5 records, top 10 records of your data that you have stored in this data set, right? So over here, now you can see that you will need to separate out the X and the Y, right? You can't directly use it as is. You will have to separate out the X, which is the features, as well as the target. Has everybody understood this? So why are we doing this? So that we can separate it out. Correct? Now, if you want to separate it out, what is the command that we have to use? We have to use the drop feature from the data frame. So this is iris, right? So X equals to iris is my data frame name, and I will drop something over here. And what is it something that I will drop? I will drop my species column, and I will just mention access equals to 1, which means I want to drop my column. That is what I'm telling it to do. And then for Y, I will just say pick iris species. Now, if we look at X, I'll go back to the code, don't worry. X is looking like this. It does not have my species column, right? Did everybody get till here? Everybody understood? You can see that X is a combination of all the features that we have. And at the end, what we have is Y now. So let's display Y. And Y is nothing but my species over here. All the species of the flowers that I can see. So we have been successful in separating out X as well as Y. That is nothing but a feature variable as well as the target variable, right? Which is what we should be doing, right? Now, moving on. So this is our module 2, that is splitting your data set. Okay. So any questions that anybody has at this point of time? Any questions before we go to module 3? No questions? If there are any questions, I'm looking at the chat only. If you have any questions, please post them on the chat. No questions. Okay, fine. All right, then I will move to the module 3, where we'll do an introduction to scikit-learn, which is the sklearn library. We'll tell you which model to choose, which is nothing but your decision tree classifier. Then how do you really fit this model? And then predicting with model.predict. Okay. So that's exactly what we'll do. These two last two we will do on code. The first two we'll just explain conceptually. So what is scikit-learn? It's the most popular ML library in Python. So you see anybody doing any ML code, it's all scikit-learn for sure. And why do we select that? Because it's very easy to use and it has a consistent interface. And what are the key components of it or the key functions that you use as a part of it? One is model.fit, second is model.predict, and third is model.score. So what happens with model.fit? It trains your model. That is, it will learn all the patterns. Then what is model.predict? It is something where you can use for predictions. Okay. And third is model.score, which is nothing but evaluation of your model. Okay. So in scikit-learn, you can do all of these things. That is, anything and everything related to machine learning is something that you can do via scikit-learn. Okay. So it makes your life very, very easy with respect to machine learning. Okay. Now, let's move to why would we choose our first model as decision tree classifier? Now, what is a decision tree classifier? It is nothing but a tree-like structure, okay, which will help us to make decisions. And why do we need decision trees? Because it will help us to arrive at a decision. So if you think of it, many of the times in life, you might be stuck with certain problems, right? What do? You try to draw a tree, right? If I am here, what are the two options that I have? What are the n number of options that I have? Say at 6:30 p.m., I have the option of joining the Let's Upgrade bootcamp, yes or no. I have two options only, no? Yes or no. I cannot have a third option, can't say. It can be either yes or no. Say you choose the yes option. Then in the yes option, what will you do? Will I get to learn new things? Yes or no? So depending on where you are with respect to your machine learning knowledge, you will either get to learn new things or you will just maybe revise it or practice it further. So that is nothing but a no option, right? And if you get to learn, then what next? Will I be able to build a project next or not? So that's nothing but a tree, right? A decision tree which helps you to take decisions. Why do we go ahead with this approach? It's very easy to understand and it does not need any feature scaling. It typically does not need any kind of feature scaling. And it works well for small data sets like iris as well. So that is the major reason why we go ahead with decision tree classifier. What is a decision tree? It's more like human decision making, right? Like it's like 20 questions. Like is petal length less than 2.5, then it will be a certain species. If it's greater than 3, then it will be another species. You keep splitting data until it can really classify or decide that, okay, this is the option that I want to go with. Okay. Now, this is the code that we use for the modeling from sklearn.tree, import decision tree classifier, and then model equals to decision tree classifier function. That is what is the major modeling function that is used. Okay. So let me just go back to the code and we will try this now. Just let me know once my code is visible. If it's not, let me know. Okay, there is one question. How is feature scaling not needed in decision tree? So you don't need it because the decision tree algorithm itself is able to deal with imbalance in the scaling of features. It does not need a constant feature set which is very well balanced. So it can deal with the rest of the stuff. Okay, so that's the major reason why it is present in a certain way, or that is how it should be in terms of how to really go ahead with the entire task of modeling. Okay, so now let's just model this. My code is visible, right? Okay, so what we'll write is from sklearn.tree import decision tree classifier. Okay, now once I have done this, my next step is to write the model, which is model equals to decision tree classifier function. So how do we do that? Model equals to decision tree classifier function. You execute it. So my model right now has the decision tree classifier model in it. Now the next step is to train the model, to fit the model. So for that, what do we use? We use the function called as model.fit. And what do we pass to it? The x and the y features, right? Where x is the features and y is the target, right? That is our basic task. That is to be able to fit the model. That is, it should get the maximum learning out of it, right? That's the basic task. Now, while you're doing that, what is the next step after fitting? So while you fit, what happens at the back end? The model is learning from all the data that you've given, all the pattern that you've given. So whatever it's learning, it will help you to predict further. So while it's doing that, what is the kind of syntax that you need for predicting? So you can use model.predict, which we saw earlier as a step. So what we use over here is predictions equal to model.predict of x. So x is nothing but your features. You pass to it, and on the basis of that, the model will use the predict function to predict and to get the probable values and store it in the variable called as predictions, right? That's what it will do. Now let's print predictions to see what kind of output it has really generated. So it has predicted that my top first five variables are nothing but what are they? Setosas, right? Quite possible, right? That all of them are setosas. But that's not the case because if you look at Iris, oh, it is the case. Sorry. So first five are setosas. So it has given the right prediction. So it was given only this X values, right? It was given only sepal length, sepal width, petal length, and petal width. It has predicted the species accordingly. So it has predicted the first five values as setosa, which is correct, which is matching the actual values, right? So that's how we can judge or decide whether the model is good enough or not. Okay. So that is exactly what we have done. That is, we have built a simple model, a very simple model, which does not have any complications today. Nothing at all. All that we've done is building a simplistic model with no divisions or anything. Tomorrow, when we go to the next steps, we will go towards the training part, the testing part, and the evaluation part, which is the most important part in any kind of experimentation that you're doing, right? So your data pre-processing and cleaning is what we will look at tomorrow. Then we look at model training and evaluation. Then we look at predictions. So till now, all that we have done is we have trained a simple model and we've got its predictions. That was a basic task for day one with a very, very simple model. So that's why we will look at the splitting and all tomorrow. So you don't have to worry about that in case those are the kind of questions that you have. So we will be doing all of that tomorrow. So don't worry at all. So this is basically the end of module 3. So now we will just open the floor to any questions that you would have. So if you have any questions, please feel free to ask me at this point. Also, some of you asked me about my LinkedIn profile. You can just scan this QR code which is present on the screen, um, which will help you to, get my LinkedIn profile and you can just connect. Now I am opening it to questions. So all the questions that are there in the chat window, I'll answer all of them one by one. So you can ask me anything and everything that you have. Okay, ma'am, we are not going to split the data set into train set. That is for tomorrow. We'll do the training and testing split tomorrow. Then it's showing 000 instead of Setosa. So Setosa has been given a label of 0. So if you see this, right, like if you see the code, let me just go to this tab, sorry. So if you see this, the target that you have, iris.target, 0 is for Setosa. So if you see the first five records, they're Setosa. So Setosa has been labeled as 0 at the back end over here. So that's exactly why it's giving you 000 instead of Setosa as an output. Can we use Python? You can use Python, totally up to you. Why are you not using TensorFlow? We are going in an incremental way. Right now, we are learning about scikit-learn. That's why we're not going to TensorFlow. Scikit-learn is a step below TensorFlow, after which you have TensorFlow and Keras and PyTorch and all the latest libraries. Ma'am, will you share a PDF of what you have learned today? I will share the PPT. I will share the code file. That makes things easier for you. Anything else that you would need? Any other questions that anybody else has? I'll just check if I've missed anything from before. I'm not answered. Any other questions that you folks have? I know some of you really like the session. Thank you for the feedback. If there is any feedback, also please feel free to write it on the chat window. I am open to take any kind of feedback that you would have as well. What's the difference between an algorithm and a model? Algorithm is the logic that is used to work with the data, and model is something that is going to be built on the data. So algorithm and model are different in those aspects. You can do this in Jupyter Notebook, totally up to you. Where will the PDF be shared? Sorry, be shared. It will be shared with you on the link which was mentioned, right, by the team at the beginning. There is a link which you will find just below in the description box. So if you look at the description box, there is an all-in-one documentation where you will be able to see all the documents. I did not use two methods. Oh, I did use two methods to fetch the data. That is correct. We used one model and two different ways to fetch the same data. It's exactly the same data. What setosa? Setosa is a species. It's a type of a flower, basically. Do you have to upload in LinkedIn? No, no, you don't have to upload in LinkedIn. That's just a QR code for a lot of you who wanted to connect with me. So if you want to connect with me, or if you have any doubts or questions or would want to know or connect in the professional setting, that's what is the LinkedIn profile which has been shared with you and it's on the screen. Do we have to upload, post the final project? No, no, you don't have to post anything over there. You can use pandas as well. Algorithm and model typically are the same thing, but as I mentioned, right, how you use it and in what perspective do you use it makes a lot of sense. What is the other question? Suggest some best model to strengthen a resume. Resume depends on the project that you're working on. So a lot of good projects will enhance your resume, and that's how you will get a good job ahead. What are the other questions? Any other questions, guys? Or are we good for today? Everybody is geared up, cheered up right now. Any questions? I'm just looking at the chat. If there are any questions, I'm happy to answer. So today we did a basic model which predicts a species based on width and other stuff. Yes. It won't help as a mini project to add on GitHub at the moment because a lot of people would have already added this. So you should do some unique projects to be added on GitHub. You can download this Iris CSV file as well. What should be a good ML project? That's a very good question. A good ML project is the one which is solving problems which you have around you right now. So you should ensure that the data that you're taking and the problem that you're trying to solve is mimicking a real world problem. So make sure that you are answering those questions first. That is, you are able to mimic that. What is this model about? So as we mentioned, right, this is a decision tree classifier. And what is a decision tree classifier? A decision tree classifier is nothing but a model which helps you to take decisions on the basis of a tree-like structure. In the same way that you typically solve your life problems as well. Pollution tracking is a good problem statement. Try and build a project on that. Yes, and we'll be coding along a lot tomorrow as well. So all of those of you who are going to be joining tomorrow, make sure that you have your collab notebooks with you. Uday, right now we cannot do that because the agenda is very set and very clear. So I can give you ideas about how to build a reinforcement learning model. You can use VS Code as well. Idea for ML projects, I think the best idea is GitHub, LinkedIn posts, and a lot of news. Okay. So you can use those parameters to work on. Sure. I think we are good then. So yeah, I am done from my side, and I think I've answered almost all questions as well. So that's good. Thank you guys. Thank you everybody. Thank you everybody for joining. It was great teaching you guys. There is no count of ML models, so don't worry. So yes, tomorrow we'll be coding along, so that's not a problem at all. Thank you everyone. See you tomorrow. Thanks a lot.